Good evening, Professor. This is Jia. I'm presenting my final project, Time Series Analysis of Coffee Bean Price. Introduction. So as you may know, coffee has become one of the most important cash crops in the world. Recently, I become a coffee fan, so I want to know how coffee price changes over time. The dataset I used is from Microtrends. It has the daily coffee price from 1973 to this year. And the dataset I used is from 2010 to last year. And it has more than 2,000 entries. So here is a time series plot for the daily coffee price over time. As we can see, it's probably not stationary. We have peaks here, and it changes. It has ups and downs over time. And I did a ADF test. We have a p-value is greater than 0.05, so we conclude the series is not stationary. So then I decided instead of using the coffee price, I calculated the percentage change for the coffee price, and I graph it here. So it almost seems like a white noise to me. And I also did the ADF test for this series, and I conclude the series is stationary. And then I graph the ACF and PACF for the percentage change of coffee price. As we can see, both ACF and PACF, they cut off as first leg. So the possible models are AR1, MA1, and ARMOR11. And then I draw a histogram for the percentage change of daily coffee price. It looks normal, but actually when I did a normality test, it's not normal. So this is the first model I built for the full dataset. It's the AR1. As we can see, the residue looks more like a white noise, and the ACF of residues are within the boundaries, and the QQ plot very closely follow the straight line. And for the Duan box test, the higher the better. So I would say almost all the values are above the 0.05. So we can say there are no serial correlation. Also, I draw a histogram for the residues. And here is another model. As we learned from the homework, sometimes we probably have more than one model fits the data. So I did the same thing. So it all looks good. The ACF of residues are within the boundaries. QQ plot looks like very closely follows straight line, and Duan box test above the dotted line, the threshold 0.05. Also, I draw the histogram of residue. Also, it doesn't look like it's a normal distribution, but it's very close. And here's a third model I built. So it looks pretty much the same, but I think the p-value for the Duan box test are like kind of like not as much higher as before. And also when I compare the p-value for the coefficients, for the previous two models, the coefficients are significant, but for this model, no coefficients are significant. And then I did the train and test split. So we have more than 2,000 entries, I split into train and test. The train has about 73% of data, and test has about 26.5% of data. So the first model I did is the AR1 for the train. As we can observe from the residue analysis, it all looks good. And then I did a forecast using then I did a forecast for the test. As we can see, the darker blue band is 80%, and the lighter blue band is 95%. As we can see, majority of the forecast can fall into the confidence interval. So we have a very good model. And then I also did a graph compare the actual and the one-step fitted value. So as we can see, the orange line is the one-step fitted value. Although it's kind of far away from the blue line, but we can see it also have the characteristic of the white noise as the blue line is showing, and also a mimic the like the magnitude of the oscillation of blue line. So it looks pretty good. And for the test dataset, I also did a residue analysis, so everything looks good. It actually looks pretty good because for the p-value of the Duan box test is pretty high, and this is pretty much follow the QQ plot of the straight line. And this is the MA model for the train set. So pretty much the same, everything looks good. The Duan box test looks good, and ACF residue within the boundaries and QQ plot closely follow the straight line. And this is also very similar to the AR1 forecast. So the forecast, the test data set, the majority of test data set are within the forecast confidence interval. So it looks very good. And for the train, the MA model, I also did the actual compare with the one-step fitted value. So the orange line closely mimicking the oscillation of the blue line, and also capture the characteristics of blue line as the white noise. And for this is the residue analysis for the MA1 model, so everything looks pretty good. The Duan box test looks very good. All the p-values are higher than 0.05. The normal QQ plot closely follow the straight line, and the ACF of the residues are within the boundaries. And finally, we have the test model comparison. So we have two models, AR1 and MA1. So first we compare the information criterion. So we compared AIC and BIC. So and we only compare the magnitude, and we don't care about the sign. So for both AIC and BIC, for the magnitude of them, the smaller the better. So we can see the MA model is better regarding the AIC and the BIC. And then we also compare the error terms for those two models. So the error terms is also the smaller the better. So this time for the RMSE, the AR1 model is better, but for the MAE, the MA1 model is better. So I give a star when the model is better than the other one. So the MA1 model wins 3 times, as the AR1 model only wins 1 time. So I conclude the MA1 model is better. But actually, I think both model, they are like were similar to each other, because I mean the number are very close. So I think both model will be a good fit for the data, and it will be appropriate to do the forecast, as we seen from the graph I shown before. And here is the equation for the AR1 model, and this is the equation for the MA1 model. And for future research, I mean, when I started this research, I found out, I learned something about commodity. And so I think in the future, I will include other commodity and cash crops like soybean and gold, oil. So I want to know how they move differently or pretty much the same over time. Also, I read about the article about the coffee in India, and they suggest they will use the ARIMA N model. So it's a hybrid model using ARIMA and artificial neural network. So if I have more time, I'll definitely try this model. And also, I want to do another different model. I guess I will introduce other factors that are related to the price of the cash crops, such as freight cost, weather, and etc. And also, since some investors can use commodity use like a hedge against inflation, I'm interested in exploring the relationship between commodities and inflation over time. And here is a list of reference I used. And then I got 2 interesting quotes I found for coffee. I hope you enjoy my presentation. Thanks for listening. Have a great time. Bye.